Okay, here we go. More on adding and subtracting with exponents. This doesn't have to be extremely difficult if you just take your time and make sense of what you're doing. We've already determined in the last lesson that to add or subtract exponents, the bases have to be the same, the exponents have to be the same. Coefficients do not have to be the same. Also, when adding and subtracting with exponents, the exponents will never increase or decrease in value. So if you start out with x squared, you'll end up with x squared, whether you add or subtract. Bases and powers must be the same. So here's an expression. X squared plus y plus 3y minus 2x squared. Following the things that we talked about in the last video, in the last lesson, what we want to do is begin by regrouping and putting the like terms together. I always start with the first one and try to match it up with what it's like. The base is x, the exponent is 2, so I look through the rest, and here's another term that has the base of x, the exponent of 2. This coefficient, it doesn't matter that this coefficient is minus 2 or negative 2, and this one is 1. The coefficients don't matter. It's the base and the power. So the x squared minus 2x squared goes together. Now I move to the second term. So y to the first power, here's another y to the first power. So these two get put together. And regrouping, here's what I have. X squared minus 2x squared. I have one of these, two of these, and I'm going to subtract. It's going to be 1 take away 2. 1y plus 3 more y's. And so the answer would be negative x squared plus 4y. 1 take away 2 is negative 1, and this is how we would write negative 1x squared. Continuing on with something a little more complicated. Yeah, looky there. Woo! Woo, doggy! We likes that. Here we go. I have an x to the second and a y. So I look through the rest of the expression for an x to the second y. And here we go. X to the second y. So those two will get put together. I'm going to underline those two. Now I have a 9y to the first power. And through the rest of this expression, I have no more, just y to the first power. Likewise here with this x to the first power. There are no more x's to the first power. A y squared, there's a y squared here, but the base is actually xy squared. This is not xy squared, it's just y squared, so we cannot combine these two. Xy squared, xy squared, these two are going to get combined, so I'm going to circle those. So when I regroup, here's what it looks like. I put these two together here. Nothing to combine that with. Nothing to combine that with. Nothing to combine that with. But these two here get put next to each other. And now I'm ready to go on. 3 plus 5 is 8. 9y, 4x, 3y squared, negative 2 minus 6 more, negative 8. Now, the order that I have these in isn't correct. When you write a polynomial, that is an expression that has more than one term. This one has 1, 2, 3, 4, 5 terms. You put them in alphabetical order with the greatest exponent of what comes first in the alphabet first. So in this whole polynomial, we have x's and y's. So the x's are going to come first, and the x with the greatest power goes first. Here I have x squared, x to the first, x to the first, y squared. The x's come first. The square, or the power of 2, is the greatest for the x's, so it's 8x squared comes first. This is x to the first power. This is x to the first power. If you were looking up in a phone book, the a's come first in the phone book, and I don't know, maybe a company has the name A. It would be listed in a phone book before a company that had a name AB. Using that logic, X would be listed before XY. So plus 4X minus 8XY squared plus 9y plus 3y squared. Now, the y's, it doesn't matter. And you might ask, well, how come you wrote 9y before y squared, 3y squared? We could just as easily swap those two, but it's the x's that matter. Actually, it would be correct in this example to put the y squared first, so I'm going to go ahead and do that. And there you go. That's the polynomial in the correct order. Moving on. What if we have groupings like this? Oh yeah. Oh yeah. What do you call this? Distributive property. We have distributive property here, and we have distributive property here. Here, everything on the inside gets multiplied by 2. Here, everything on the inside is going to change its sign. The positive 4ab will become minus 4ab. The plus a squared will be minus a squared. The minus b squared will be plus b squared. It would be the same as multiplying everything on the inside by -1. So here we go. Multiply everything in here by 2. Changed the sign on all of these. Here's what we end up with so far. Now it's time to regroup and combine like terms. I have 2 ABs. Here are more ABs right here. So I'm going to underline those. They are like terms. Here's a B squared. And here are more B squares. So I'm going to circle those. Now I write them next to each other. 2AB minus, don't forget to take that minus sign with the 4AB, minus 4AB. Then the plus 6B squared plus B squared minus A squared. When we combine those, 2AB minus 4AB is negative 2AB. 6B squared plus B squared, 7B squared. And then this lonely minus A squared here at the end. Now putting them in alphabetical order with the highest exponent first, negative A squared minus 2AB plus 7B squared. Remember, it's the A's that we get in order. The B's just follow along. It does not matter that the B squared is here at the end. That's where it belongs. Okay, so let's try something maybe a little bit more involved. Let's see, we got x to the 5th y. No. Oh, here's more x to the 5th y's. Those get put together. X to the 6th. X to the 6th. Actually, I'm going to change those. I forgot to change these. Let's change these to the 5th power. X to the 5th, x to the 5th, but there's no y with that, no y with that, so they can't be combined with those. So these two are alike. I forgot to change these in my example. Here we go. Alright. So these two are alike. Here they are. These two are alike. Here they are. And this lonely, lonely y. But why? But why? I don't know. Now we combine them. X to the 5th y plus 7x to the 5th plus y. What should come first? Alphabet first, then powers. X to the 5th, then x to the 5th y. X would come before xy in any alphabetical list. So the final answer is 7x to the 5th plus x to the 5th y plus y. All right. Let's move on from the x's and the y's. We want to forget the x's, right? Do you know why? Ha 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 ha. Okay. 8ab plus 6b minus 3ab plus 5b minus 6. Now this one has a constant. A constant, you remember, is a number that doesn't have a variable with it. When you're writing polynomials, the constant will always come at the end. Always. That's where they belong. Alright, so here we go. 8ab minus 3ab. 6b plus 5 more b's. We regroup those. 8ab minus 3ab. 6b plus 5b minus 6. Combine the like terms. 5ab plus 11b minus 6. And now, let's write it in the proper order. Alphabetical first, looky there. A comes before B, so this one would come first. Plus 11b minus 6. There you go.